Yeah, hello everyone. A very good evening. So we will start the session within 5 minutes. Let's wait for everyone to join in. Okay, so let's start the session. Hello everyone, a very good evening. My name is Pooja Verma. I am PMIS Research Scholar from IIT Kharagpur, and the course instructor for this course is Dr. M.K. Bhuvan, Department of Electronics and Electrical Engineering, IIT Guwahati. This is a week 8 live and interactive session on computer vision and image processing fundamentals and applications. So I hope all of you have gone this week video lecture. So any one of you can confirm it whether I am audible and visible. Is it audible? Okay. So this is a week 8. So again, we will solve some problems based on the image descriptors and features. And these are the textbook and web pages. I hope all of you are following this. Okay, so this is our first question for this week. Which property of a chain code is achieved by taking the first difference of the sequence? Option A is scale invariance, option B is rotation invariance, option C translation invariance, or option D is start point invariance. Can you answer for this question? Then we will discuss in detail. We will see the detailed explanation. At least try to give answer. Which property of a chain code is achieved by taking the first difference of the sequence? Okay, someone is answering option A and another option B. Okay, so let's see the detailed explanation is here. So we will go to the option by options. So first option is scale invariance. So in standard chain code and their first difference are inherently dependent on the size of the object. And scaling an object changes the number of boundary pixels and thus the length of the code. And scale invariance is typically achieved by resampling the boundary at a different grid space. So this is not scale invariance is not a correct option for this one. Another one is a rotation invariance. So taking the first difference of a chain code sequence generates a differential chain code. If you have solved any problem, then you have checked there in chain code. We have to generate a safe number, right? So for that, we have to take the first difference and then make it rotate to get the smallest possible number. Right? We will see the questions. I have some questions based on that. We will solve that one. Okay. So which represents a change in direction between the consecutive segments rather than the absolute direction themselves. So this property ensures that if the entire object is rotated, the relative change between the segments remain the same, and that makes a code rotation invariance. So this that process involves calculating the number of counterclockwise direction changes between the adjacent elements in the original code and the treating the code as a circular sequence to ensure the transition between the last and first element is also captured. That should not be left. And our next option is translation invariance. So basic chain code are already translation invariants because they record relative modes from the starting point rather than the absolute Cartesian coordinates. So taking the first difference is not required to achieve this property. And our last option that have been given, that is a start point invariance. Just So the first difference itself still depends on the starting point of the boundary trace. To achieve start point invariance, the first difference must be first normalized by finding the circular shift that results the integer of minimum magnitude. that is also called a shape number. So the correct option is the rotation invariance. This one. So the rotation invariance property of the chain code is achieved by taking the first difference of the sequence. This is the option B is the correct answer for this question. Now we will move to our next question. Is it fine? Have you understand? Why? Okay. So now moving to our next question. Now our next question is, which of the following statement is false about signature in the object representation? Option A is this is a 1D representation of a boundary. Option B, the distance from the center point to border represented as a function of angle. Option C, independent of the translation, rotation, and scaling. And option D is none of these. So they are asking about the false statement. Okay, which of the following statement is false about signature in object representation? Okay, the giving answer is B. Okay, okay, option C. Okay, so let's see the explanation is here. Yeah, so a signature in digital image processing is a 1D representation of the shape's 2D boundary. So the signature in image processing is represented by a is representation of a 1D that is shape 2D boundary. While the standard construction methods make it invariant to translation, it is not inherently independent of the rotation and scaling. So this is 1D representation of a boundary. This is our first option. So this is true because a signature reduces the 2D boundary into a 1D functional representation to simplify computation and comparison. So this one is a correct option A. And our next option is the distance from the center point to border represented as a function of angle. So this is also true. One of the most common ways to generate the signature is by pointing the distance r from the object's centroid to its boundary as a function of the angle theta. Right? B is also the true. And our option C is independent of the translation, rotation, and scaling. So this is a false because in the translation it is invariant because the distance is measured from the centroid, and the rotation it is independent on the rotation because the starting point of angle theta changes unless normalized by the starting from the furthest from the centroid. And scaling, so it is also dependent on the scaling because changing the size of the object changes the amplitude of the distance, that is r of theta, unless it is normalized. So the statement independent of translation, rotation, and scaling is false because a standard signature is only naturally invariant to translation, rotation, and scaling that requires additional normalization steps to achieve independence. So yeah, correct option is C. The false statement is independent of the translation, rotation, and scaling. It is dependent on the translation, rotation, and scaling. Okay? Yeah, it's C. C is the correct option from the given for the given question. Is it fine? Now, can we move to our next question? Okay, so now moving to our next question. Our next question is, which of the following statement is false about B-spline curve? So again, they have asked for the false statement. So be very careful about that. So options that is given, option A is B-spline curve of order n is piecewise polynomial function of degree n minus 1. Option B is it is necessary for blending function to become non-zero. Option C is B-spline curves provide the local control through control points over each segment of the curve. And option D is the degree of B-spline curve polynomial does not depend on the number of control points. Which option can be a correct one? Here, which statement is false about B-spline curve? So again, they have asked for the false statement. Okay, B. Anyone else? Which option can be a correct one? Okay, so let's see the explanation is here. So we will go by options. So option E is B-spline curve of order n is a piecewise polynomial function of degree n minus 1. So this is a true statement as regard to the standard definition. So the order of n is defined as the degree of k plus 1. So that is n is equal to k plus 1. So the curve of order n has a degree n minus 1, right? So now next option is option B. It is necessary for blending function to become non-zero. So in B-spline theory, it is not a requirement for the blending, that is a basis function, to be non-zero everywhere. In fact, the a fundamental property of B-splines is their compact support, meaning each basis function is zero outside of the specific range of knots. So this specific property is what enables local control because of the blending function is zero for most part of the curve. That moves a single control point to only affect the segment where it is corresponding blending function is non-zero. Okay, so this is not a correct option. It is not necessary to non-zero everywhere. Okay, and option C is the B-spline curve provides a local control through control points over each segment of the curve. So this is a true statement and that defines the advantage of the B-splines. Unlike Bezier curves, changing one control point in a B-spline only alters the local parts of the curve because the basis functions have a local support. Now option D is that the degree of B-spline curve polynomial does not depend on the number of control points. So this is also a true statement. In the B-spline, the degree is a parameter that is chosen by the user and is independent of the number of control points. So this differs from the Bezier curves, where the degree is strictly n minus 1 for n control points. So the correct statement is B. It is necessary for blending function to become non-zero. It is a false statement about the baseline curve. So option B is the correct answer for this question. Is it fine, everyone? Okay. Now moving to our next question. So now our next question is, The 8 connectivity chain code of the following shape is given as. So this is the 8 connectivity chain code. Here it is given, and this is the direction that have been given, right? So how we can find out the chain code for the following shape? Anyone? Any idea? Directions are also given. Direction numbering is given. Then we will solve it. Yeah, based on number, two directions we will count. Okay, we will see. Okay, so we will follow the direction. Okay, so we will start from here, right? So first it is moving in this direction, right? In this direction. So it is like this in this direction only. So what we can write out here? 7, right? Now next it is a straight here. So what we can put here? For the downward side, it is the numbering is 6, right? 7 and 6. Then again here it is in this direction. So that means in this position it is there. Like see the directions in this one. So again 7 it is here. Now it is moving in this direction. So we will just match with this one is matching with this direction, right? So it should be 5 here, 5 because in this direction it is given as a 5, number is 5. Again it is again downwards, like straight downward. So it is again 6, right? Now again it is next for the next stop, it is again the downwards continuously. So 6 again. Now it is in in this way, right? So this is in this direction, that means in this, so it is represented by 0, right? It is represented by 0. So here it is 0. Now again, this direction has moved in this one, right? So this one, what is represented? This, I mean that direction, that 1. So here it is 1. And again, it is a straight. Here it is a straight. So again, it would be 0 because in this direction it is a 0. Again, it is a two consecutive blocks. It is a downwards. So downward symbol is 6, right? So 6, 6. Again, it is moving in this direction. That means here, this direction is matching with this one here. So what is it? It is 5. So again, it is moving in this direction. So thus opposite. So it is a 7. So just write down what is the from starting to end. 7, 6, 7, 5, 6, 6, then 0, 1, 0, 6, 6, 5, 7, right? So just match with the options 7, 6, 7, 5, 6, 6, 0, 1, 0, double 6, 5, 7. So it is matching with the option B, right? So option B is the correct answer for this question. Have you understand? Yes. Just we need to follow the direction. Direction chart is given here. So it is also suggested here. The arrow is given at move in this direction. Okay. So just we need to follow the black holes, or we can say that black boxes. Okay. So I hope all of you have understand this question for the 8 connectivity chain code. Okay. So now move to our next question. Next question is the cyclic shape number for the given of the figure of question 4 is. So now they are asking for the what is the cyclic shape number for the previous figure that is given in the question 4. So how we can find out the cyclic shape number? Anyone any idea how to find the cyclic shape number? So already we have calculated the chain code, right? Is it A? Okay, we will solve it here. So any idea how to solve this question? Okay, so let's solve it here. So what is a cycle here? They are asking for cyclic shape number, right? Difference between subsequent digit and first digit is the difference to the last and first one, right? So the shape number that is defined as the first difference of the chain code and the results in the smallest magnitude when treated as a single number. Okay, so already uh, chain code that we have got from question number 4 is what is it? 8 directional chain code that we have got 767 500 6657, right? So now what we need to do, we need to take the first difference of the chain code that is calculated by taking the difference between each adjacent pair of the digit module n. Here n is 8, like it is a 8 connectivity chain code, right? It is given. So it is a 8 connectivity code. Connectivity. So n is equal to 8. It is here. So how we can find out the difference? So let's say the difference di, that is represented by ci minus ci minus 1 mod of 8, because it is a 8 connectivity. Here in the normal terms it is written mod n. So here n, our n is 8. So we will calculate it in the mod 8. So how we can? So for first one, what is our the difference from where? From the last one to first one we have to take a difference, right? Because it is a closed loop. So for the first, it is from 7 minus 7, right? So mod 7 minus 7, mod 8. So I'm directly writing it as a 8, not always mod 8. Okay, just understand. So 7 minus 7 is 0, right? Now next one is here 6 minus 7, because we will take a difference like this. This here again it is this like. Okay, so 6 minus 7 mod 8. So here minus 1 of mod 8. So it is a mod 8. So it is not a minus 1. We can't represent in this one. So for mod 8, 7. So 8 minus 1. So it will be the 7 only. Right? Because in the mod representation, is it fine? Have you understand why we are writing here 7? Because it is a mod. Is written here. Okay. So we are taking the mod difference. Now next one is 7 minus 6 mod 8. So here it is a positive number. So it is a start 1 to 8. So it will be 1. Now next one is 5 minus 7, right? 5 minus 7 mod 8. So mod of minus 2 minus 2 of mod 8. So here If you just make a difference, so here you will get 8 minus 2, 6. Right? Now again, 6 minus 5 mod of 8. So here 1, here you will get 1. Now next one is 6. So 6 minus 6 mod 8. So here you will get 0. Right? Now the next one is 0 minus 6 mod 8. So here you will get minus 6 mod of 8. If you again take a difference, here you will get 2. Right? Now next one is 1 minus 0 mod 8. So here you will get 1. Now next one 0 minus 1 again. So minus 1, 8. So here you will get 7. Right? Now I'm just writing it here. Okay. So 0 minus 1 till now 1 next these 4 bits are left. So 0 minus 6 mod 8, right? 6 minus 0. 6 minus 0. So 6 it will left only. Now again 6 minus 6 mod of 8, 0. Then 5 minus 6 mod 8, it is 1. And last one is a 7 minus 5. So it is 2. Right? Now what we have got the state number of this code, chain code. I'm just removing it from here. And then we'll write it here. So what we have got 0, 7, 1, 6, 1, 0, 2, 1, 7, 6, 0, 1, 2. Right? This number we have got after taking a difference. Now what is our next step? What we need to do? So can I remove this part? This part, the remaining part? Any one of you? Have you understand how we are getting this one? Any doubt? No. Now we have to find the smallest cyclic shift. No, this is not a final answer. So have you understand till now? Second last digit by 5 minus 6, right? What is our chain code? 5 minus 6. Okay, yeah. Just not 5 minus 6. Yeah, it is minus 1. Yeah, correct me now. Thank you for correcting me. It is minus 1 mod 8. So it should be 7. Right? Yeah. Now it's correct. Everything? Yeah, correct. Okay. So we have got this. Now what we need to do? We need to calculate the smallest cyclic shift of the sequence to evaluate the every possible starting position of the sequence and identify which resulting rotation forms a smallest numerical value. So what we need to we need to make a rotation here, like shift first bit to end. Then just check. So how many numbers are there total? There is a 13 number, right? 13 numbers are there. So their possible cyclic shift would be 13. So every shift we have to shift each digit to the back side and just check which number is the smallest, and in the options we need to check. Okay. So this sequence will be treated as a loop. So there will be the 13 starting points. So now I think this part is clear, so I'm just removing for the next part. Yeah, after finding this, whether it is necessary to select the smallest numerical sequence. Yeah, is it necessary? It is necessary to find the smallest numerical sequence. Okay, so here total number numbers are, that is 13. So we have 13 possible starting points by shifting points. Right. Now, what we do, the first sequence will be this one. So there is a zero rotation, like we will represent index zero. So there is a no rotation, right? Or you can say no cyclic. So 0, 1, 0, 7, 1, 6, 1, 0, 2, 1, 7, 6, 0, 7, 2. Now next, I'm just representing it 1. That means 1 bit shift. So it will move to the last one. So 7161021760720. Right? Now we have to check again. So for now the second shift, that means this 7 will go this side. So again the number will be 1610217607207. Right? Now next shift, what will be the number? 610217607207. Right? Now the fourth shift will be 1021760720716. Now check for the fifth one. Now 02176072072161. Right? Now just check for the next one. So 2176072071610. Now next one 7. So 1760720716102. Now the next one 8 one. So 7607207161021. Now then just I'm writing here. Only 5 left. So ninth position. So 6072071161021. Right? Now the 10th one, 072071610217. The 11th one, 7207161021760. Like that, you can just check for the 12th position as well, right? Then again, you will get now two more next shift. So now from this point, also you can check and see which is the smallest positive number in this six. So if you just check the index 5, this one is the smallest, right? The smallest one, the smallest number. So this is the correct answer. So if you just match, so if you match it, you will get the option B is the correct answer. And the other options are not matching itself from the given cyclic itself. Yeah, the option B is the correct answer for this question. 021760 7207161. This one is the smallest one, right? Is it fine to all of you? Any doubt? Anything? Okay, so I hope all of you have understand how to find the cyclic shape number from the given chain code. Otherwise, the some sequence are given. They can ask about the cyclic shape. So I think you can find out it like this. Okay. So now moving to our next question. So our next question is the Euler number of the following shape is. What is the Euler number of the given shape? So how we can find the Euler number from the given shape? Anyone having any idea how to calculate the Euler number? Option A. Okay. Did minus holes. Yeah, correct. So the Euler number of a binary image is calculated by E is equal to C minus H, where C is the number of connected components and H is the number of holes. So if you see in the image, in the given image, if there is a how many connected components are there and how many holes are there? Can you tell me how many connected components and how many holes are there? If you just see three holes are there, right? That is not the dark gray are the connected components. The remaining one are the holes, right? There is no filling are there. So connected component is one here because only one connection is given here, the both triangles. So if you see here, just a minute, number E is calculated at C minus H. C is the connected component and H is the number of holes, right? So how many holes are there? One, two, three, right? That is correct. Three holes are there. So minus three. How many connected components? Only one connection is there. If there is another, so that is called the two connections, right? So only one connected components are there. Only one connection is there between these two. So it is one, right? C is one, H is three. So 1 minus 3. So here you will get minus 2. Okay. So option D is the correct answer for this question. Is it fine to all of you? So have you understand from the given figure how to calculate the Euler number? Okay. So now moving to our next question. I hope all of you have understand this question. No, connected is one. If you see that only one connected components are there, no? Only one connection is doing. If this one is also gray, then it will be the two. It will be connected between the two. No, 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 not. It is counted as a one. It is a connected component. How many connections are there between each other? So it will be the counted as an individual if you are calculating like this. Is it fine, Anand? Can we move or you want more clarification? Yeah, if not connected, why 5 poles are there? Okay. So now moving to our next question. Our next question is find the chord tree representation of the figure 5. So this is our figure 5. If the division is in order of, so here the division is in the order of NE, SE, SW and NW. That is northeast, southeast, southwest and northwest. In the four cardinal direction from left to right. Okay. So given here the white pixel that is represented by W is represented by if all pixels are 1 and the black pixel that is represented by B is represented by a 0 if all are 0 and the gray pixel is represented by Z if there is a mix that is both 1 and 0 will be there. Okay. So what will be the quadrilateral representation of this figure? So the options are given. Yeah, is any problem? So how we can solve this problem? Yes, Sandeep, any problem? You want to ask anything?
No, no, ma'am.
Okay, okay. So, unmute yourself. Okay. So how we can solve this problem? If the chord-free representation of this type is given and directions are also given, now everything is represented. How we can represent this? Okay, 4 chord 4 metric. Okay, so we will solve it. So they have asked the 4 directions are given. Division is based on that only. So if you have gone through the directions in this one, so you will find out the here we are taking this part is a north east direction and this one is a SE, right, southeast direction, and this one is a southwest direction, and this one is a NW. Okay, so now first we will consider the whole figure, that whole matrix. So it is a combination of both, like 0 and 1, right? So, and what we will represent if it is a combination of both 1 and 0, it is represented by 4, sorry, Z, right? So, and we need to also arrange the order of the children based on that NE, SE, SW, and NW. So we can say that it is a level 0. So the entire grid that is contained ones and 0. So it is represented by G. So let's say it is a 8 cross 8 grid. It is a 8 cross 8 grid. The whole grid, we can say that level 0 is represented by J because it contains both ones and zeros. Now again, we will further divide it into a 4 cross 4 grid, right? So now we will divide it like 4 this, and 4 this one, right? Now again, can you just let me know what the every matrix represent this 4 crossover? What is the any represent? Can you answer? The whole 8 cross 8 grid represented by Z, right? Now further we will divide it into a 4 cross 4 grid. Then again we will divide each grid into 2 cross 2. Then what it represents? Okay, so anyone in interest? So now our let's say it label 1. So what we have done in label 1, we have just convert 8 cross 8 grid into a 4 cross 4 grid, right? Just divide it. Here. Now this direction, that is a northeast, what it is, how, what it is representing, the whole. It is a combination of ones and zeros, right? So what is it is representing? It is a Z. It is a both 1 and 0. So it is represented by Z. And now next one SE also. We will follow the same. It is containing both 1 and zeros. So it is also represented by Z. Now next we will check for the SW. This part. So if you see that all are ones, right? In this one. All are ones. SW. So are all ones it is there. So what we can represent if all ones are there? So pixel W we can represent W, right? Now next one this part NW, right? If you check here, so it is a combination of both ones and zeros, both ones and zeros. So it is a Z, right? So at label 0, it is a G, and again the next step is GG, WG we have got, right? Now again, it is a children of whole 8 cross 8 grid. This is both. Now next again we will move again 2 cross 2 grid. This one we will divide each 4 cross 4 grid. That is you can say that label 2, that 4 cross 4 grid again divided into 2 cross 2 grid, right? So in this section if you just check what is what are the values in the same direction. So anyone, any interest? Can you tell me what will be the NESE values? Okay, W. Yeah, correct. Yeah, it's because here it is any, right? We follow the same the direction. And the upper left, upper right one, it is any. Uh, the lower bottom part that is called a SE. Here SW, NE, NW. We will follow the same. Okay. So at level 2, so here NE is all ones, right? All ones. Here it is all ones. If you see, so what we can represent it? W, right? Now similarly SC also all ones. So again W. This part is also that is SW all ones. So again W and this part is all zeros. So all zero is represented by B, right? And W that is all zeros. So it is represented by B. Here it is a B. Okay. So our next, this we have got, what we have got, I can write it here again. Here W and B, right? We have got. Now we will move for the SE. This part, it is it is also a broad children of the 4 cross 4 matrix, right? So I can remove it from here, or I can write it directly there, right? Again, divide it color so that it should be visible. So next one is this part. So if you just check, it is all ones again, right? All ones. So if you see, it is a W. Here it is also all ones. So what we can write? W. And here it is again all zero. So all zero is represented by B. And here all ones again it is represented by W. right? So the next string we have got WWPW, right? We have to follow in this direction. Now, if you check this part, this is all ones, right? You can take this color. This is a all ones, right? So we cannot further just divide it. If you divide it, or you will get the all W itself. So you can write it W for whole for the south west direction. Okay. Now, if you just this color. So now again we have to just divide it 4 cross 4 grid because it can be divided. So if you check just this one, it is all zeros, right? So it is represented by B. Again, it is all zeros. It is represented by B. It is all ones. So it is divided by. It is represented by W, right? Now, if you check this one, it is a mix of both ones and zeros. So it is represented by Z. So now it is a combination of both. So we can further divide it again, right? So if you further divide it again, so if it is a combination, so you have to divide further, right? So it is a 1 1 1 0. So we can represent it like for one, it is a W, 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 and B, right? So this one, till this, it is a clear. So how we can calculating this one? Now we have to calculate for whole. So from first from the root plus any block, how many childrens and sub-childrens are there, then SC block, SW block, and E block. Okay, after calculating all those things. So now I am just removing this part. At level 0, that is 8 cross 8, we have got the yeah. So now we need to follow root, then its children, right? So now what we need to do, follow root, root plus its children. So what are the childrens are there? That is different directions, NE, SE, SW, and NW, and their sub-children as well, right? So first we will take root, then plus any block because it is in the same direction we need to check any block, then SE block, then SW block plus NW block, right? Now first root for root we what we have got for all 8 cross out grid 8 grid that is G because it a combination of both, right? So first one is G. Now for the any block what is the first 4 cross 4 grid, it is a G, right? First the whole grid, it is a G for whole this one. Then we have divided because it is a combination of both zeros and ones. So it is again G. Now we are starting from here. Then what are the different childrens of there? This one G any block sub childrens that is W W W B, right? So W W W B. Now any block has been completed. This part. Okay. Now we will move to the SE block, right? SE block. So what is the 4 cross 4 grid of that one? For whole, this one, it is again G because that's why we are able to divide it. So it is a G, right? So Then again G, we will write G, and then again its subchildren. So what are the subchildren? That is W, W, B, W, right? W, W, B, W. We will follow this only, this, because we are Northeast, SE, SW, and W, right? Now next one is a SW block. So in the SW block, if you see, that is all ones. So here no further subdivisions are possible. So we will write the whole as a W only. Now again we will go to the NW block. So in the NW block, if overall you will check, so what is the, it is a G, then it is able to divide it. Okay, we will write here G. Then its subchildren. So that the subchildren are B, B, W, G, B, B. I'm just writing here W, G, right? B, B, W, G. Now again, G is the combination of both ones and zeros, right? So now again we need to further divide it. So after further dividing one cross one matrix, so what we are getting? W, 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 B, W. Okay. Now this is our final answer. So just check in the options and which option can be a correct one. So if you check carefully, you will get option B is the correct answer for this question. Is it fine to all of you? So have you understand this question? Okay, so we need to follow the first the root, then its children, then its subchildren, and if it is a further dividable, so again its sub-subchildren, and just write in the given order only. Okay, so order is defined here, so just choose that order only. Okay, so I hope all of you have understand. So now moving to our next question. Can we move to our next question? Any doubt, any problem? Anyone? Okay, so now moving to our next question. So our next question is, suppose the sampled boundary of the object is represented by Sk and the Fourier descriptor is represented by Au. If the boundary is translated by S0, then its new Fourier descriptor will be option A is remain same except at u is equal to 0. Option B is B expanded by S0, B translated by S0, and last option is no change. Which option can be a correct one? Suppose the sampled boundary of the object is represented by Sk and the Fourier descriptor is represented by Au. And if boundary is translated by S0, then its new Fourier descriptor will either remain same or expanded or translated or no change will be there. Okay, now it's saying option A. Okay, he is asking. Okay, we will see now in details. Okay, so let's the detailed solution is here. So if the boundary of an object is translated or shifted by a constant S0, the Fourier descriptor, which is the based on the discrete Fourier transform of the complex boundary coordinates, that is a sk is equal to xk plus j by k, right? Is a complex boundary coordinate. So will generally remains the same except at u is equal to 0 term. So the property is when a signal boundary points is shifted by a constant, it affect only affects the DC component at u is equal to 0, which represents the centroid or average location of the shape. And the effect will be if u is equal to not 0, the Fourier descriptor represents the shape feature, that is edges, corners, structures, and are invariant to translation. And if it is at u is equal to 0, the new Fourier descriptors become 0 new, f0 old plus del, where del is the depends on its translation as 0. So that's why new Fourier descriptor remains the same except at u is equal to 0. Okay, this option is the correct option. That's correct enough. Okay, so I hope all of you have get this question. Okay, so now moving to our next question. So next question is, in the 8 connectivity chain code, what direction does the digit 2 typically represent? Option A is east, option B is north, option C is west, and option D is south. So can you answer for this question? In the 8 connectivity chain code, what direction this digit 2 typically represents? So we have seen one question, the different directions. Okay, north. Okay, yeah. Okay, so here the detailed description we have added. So in 8 connectivity or 8 direction chain code, which is commonly used to represent the boundary of the region, name is processing. The digit 2 typically represents the north, that is in up direction. So in the standard 8 direction 3-man chain code, the directions are usually numbered in a counterclockwise number manner and starting from the east or sometimes in a clockwise manner. So this convention cited the 8 connectivity, such as in the like mind project. So 0 represents the east, that is the right. 1 represents the east, that is east right, and northeast, and 2 represents north up, northwest in the next one, and west it is in the left, and southwest in the left corner work, like this one. We have seen like this one, right? So the correct answer is option B, that is the north, up direction. The 2 represents the north in the up direction. Okay. Yeah, most of you given the correct answer. That's correct. Okay. So now moving to our next question. Our next question is, which of the following is a global descriptor rather than local one? Option A is corner points. Option B, shift descriptors. Option C is ruler number, or option D is edge segments. So which of the following is a global descriptor rather than local one? Can you answer for this question as well? Okay, option C, I'm using ruler number. Okay. Okay, so we'll see the detailed solution is here. So first we will see Euler number. So this is the topological property of a shape or an image that represents the total number of objects, that is minus the total number of poles. Already we have seen E is equal to C minus X. So it is a single scalar value computed over the entire binary image. That makes classic example of the global descriptor. And we will check for the other what the other points are there. The corner points A. So these specific represent the specific local intensity changes, that is the interest point, in a small neighborhood, making them local descriptors. And shift descriptors also scale invariant feature transform that computes 128 dimensional vector, that is based on the gradient magnitude and orientation of a small image patch. around the specific key points that makes it also a local descriptor. And edge segments, so these are also local geometric features that represents the boundaries at a specific location in an image, and that makes them also a local descriptor. So while the global descriptors describes an entire image or object, that local descriptors describe the patches within image. So the correct answer is C, Euler number. Euler number is defined as a global descriptor rather than local one. So yeah, option C is the correct answer for this question. So all of you have understand this question. Can we move to our next question? I hope all of you have got this question. So now moving to our next question. So our next question is how many bits are required to represent a single direction in a four connectivity chain code? So how many bits are required to represent a single direction in a four connectivity chain code? Anyone, any idea how many bits are required to represent a single direction? Okay, so let's see. So as we know that in a four connectivity chain code, there are only four possible directions, right? To represent the movement between the adjacent pixels. That is right, left, up and down, right? So in four connectivity chain code, there are four possible directions to represent the movement between the adjacent pixels, right? That we have seen, that is this one, right, left, up, down, right? So to represent four four distinct possibilities using binary. So 2 to the power n is equal to number of directions, right? So 2 to the power n is equal to 4 directions are there because in the 4 connectivity channel. So that is 2 to the power n. 4 is represented by 2 to the power 2, right? So n will be equal to the 2. So 2 bits are required to represent each direction. Okay. So 2 bits are required to represent each direction. Okay, so option B is the correct answer for this question. Yeah, B, it's B correct. Two bits are required to represent a single direction in a four connectivity chain code. Is it fine to all of you? Can we move to our next question? Okay, I hope everyone is getting these points and understand. If you have any doubt, you can ask. So now moving to our next question. Our next question is, if an object is rotated by 45 degrees, what happens to the magnitude of its Fourier descriptor? Option A, they are halved. B, they remain unchanged. Option C, they are shifted by 45 degrees. Or option D, they become zero. Which option can be a correct one? If an object is rotated by 45 degrees, what happens to the magnitude of its Fourier descriptors? Anyone would like to answer for this question? Then we will see the detailed solution here. Okay, so let's see. The solution is here. So Fourier descriptors are the powerful tool for the shape description in the image processing that because of their specific invariance properties. So when an object is rotated in a special domain, its Fourier descriptors are affected in the following ways. So one is the magnitude invariance, that the magnitudes of the Fourier descriptors remains exactly the same regardless of the rotation angle, and this is because of rotation only adds a phase shift to a complex coefficient, and which disappears when I calculate the absolute magnitude. Okay. And the another one is a phase shift. So while the magnitude stays constant, the phase each descriptor is shifted by an amount of proportional to the rotation angle. Okay. So here options that are given, that is the option is they are half. So there is a no scaling effect on the magnitude of the Fourier descriptors that is caused by the rotation. So scaling the object itself would change the magnitude, but rotation does not. And they are shifted by 45 degrees. So this is a trick option. While the phase angle of the descriptors might shift the magnitude, but which is what question asked about, but not shift or change its value. That is magnitude, right? And they become zero. So Fourier descriptors only become zero if the corresponding frequency components is not present in the shape. So rotating an object does not remove its same shape information. The correct answer is option B. They remains unchanged. Okay, option B. So if any object is rotated by 45 degrees, its magnitude remains unchanged. Okay, is it fine to all of you? Okay, so now moving to our next question. So our next question is, in run length encoding, that is RLE, if a row is 11100, the code starting with the count of ones is, what will be the code? The run length row is that is given. What is the code? Anyone would like to answer for this question? What should be the answer? Okay, 1302. Option B, how? So what exactly run length encoding do? Okay, we'll see Anand. So in the run length encoding, that row is given. So is composed by counting consecutive and identical value. So RLE composed by counting consecutive identical values. Okay, so given row is type is 1 1 1 0 0, right? So how many ones are there, how many zeros are there? So we need to count just uh, count consecutive identical values. These are the three in a row. So three ones are there and two zeros are there, right? So the resulting code will be the 3 and 2, not a 1302. Because in the count, how many consecutive ones and zeros are there? So it's 2 in the conjugation, 2, and it will become, if it is some other numbers will be there, like after that 1, 0, so like something will be, then we will count it again. Okay. The consecutive identical values we need to count. So the resulting answer is 3, 2. So option A is the correct answer for this question. Is it fine? And have you understand this question? What they are asking exactly? Where it is written itself, starting with the count of ones. So just we need to count in a row how many consecutive ones and zeros are there or any other number is there. Okay. So I hope all of you have understand. So now moving to our next question. So now next question is chord tree decomposition is particularly efficient for image with option A for high frequency noise, option B large homogeneous regions, or option C complex texture, or option D random pixel distribution. We have solved one question itself. Chord tree decomposition is particularly efficient for images with high frequency noise, large homogeneous regions, complex texture, random pixel distribution. Which option is the correct? Okay. Anyone else who would like to answer for this question? We will see the detailed explanation here. Okay, so let's see. As we know that in the chord tree decomposition, that is a hierarchical data structure that is used in image processing to partition an image into a four equal sized quadrants. Right? So this process repeated recursively until the specific criteria like usually homogeneity is met. Okay. Our options are high frequency noise. So noise reduce constant variations between the adjacent pixels. So because of the algorithm requires homogeneity to stop the dividing, high frequency noise would be the force the quad tree to decompose down to a individual pixel level, so making it highly inefficient. So this is not an option. Now next one is large homogeneous region. So the key reason for the large homogeneous regions efficiency, that is a efficiency through compression. So in image with large homogeneous regions like areas where pixels have the same or the very similar color intensity, the algorithm can represent a large block of a pixels as a single leaf node, and this significantly reduces the amount of data needed to describe those regions. Like we have seen the south-west direction, all are ones, right? Because they are representing the same intensity or color. So that is represented by only W. Now next one, variable resolution. So in the chord tree structure allocates fewer bits to homogeneous region and more bits to the region containing high detail or sharp features. If there is a large variations are there, so that requires more bits. And the early termination, so the recursive subdivisions stops as soon as it reaches the homogeneous block. So as it reaches that all ones or all zeros, then it will block, otherwise it will subdivide that allow algorithm to bypass deeper, more complex computation for the sections of the events. Okay. So our next option is complex structure. So similar to noise, complex structure involves frequent changes in the pixel values. So this results in many small leaf nodes, that is a busy tree, which negates the benefits of hierarchical structure and random pixel distribution. In the random pixel distribution, there are no large area of the similar value. The chord tree would be forced to subdivide along almost every coordinate to the maximum depth, so resulting very large and efficient data structure. So correct answer is large homogeneous fusion. Okay, option B is the correct. So, chord tree decomposition is particularly efficient for the images with large homogeneous regions, not for the high frequency noises, complex texture, and random pixel distribution. So option B is the correct answer for this question. Okay, so we have seen that like chord tree is 8 cross 8 matrix is there, so we can divide it and we can do it fast, or algo can do a fast way, and it is not suitable for the high frequency noises, image matrix, or complex texture because there are large variations will be there. It is not possible for the tree decomposition in that case. Okay, so can we move to our next question? Have you understand? This explanation is okay? I hope so. Moving to our next question. So our next question is the process of reducing a binary object to a one pixel wide skeleton is called. Option A is dilation, option B is erosion, option C is thinning, option D is segmentation. So the process of reducing a binary object to a one pixel wide skeleton is called. Which option can be a correct one? Any idea? Okay, C, thinning. Okay, let's see. So in digital image processing, thinning is a morphological operation that is used to reduce the binary object to its one pixel wide skeleton while preserving its topological properties and connectivity. So we will see what the other options means. That dilation, that is that this operation expands the boundaries of the object, that making it larger and filling in small holes. So this is a process of reducing boundary object. This is the expanding. And next one is erosion. So while erosion shrinks object by removing boundary pixels, it does not inherently stop at one pixel wide skeleton. So if applied repeatedly without specific constraints, it would eventually remove the entire object. It is used for shrinking and thinning, that is specifically aims to thin down objects to their center lines or medial axis, that reduce the thickness of the ridges or lines until they are only one pixel wide. It is often used for trace cursor to feature extraction in the task like optical character recognition (OCR) and segmentation or multiviewing. This is a broader process of partitioning an image into multiple segments or set of pixels to simplify its representation rather than specific morphological operation to create a skeleton. So correct answer is the process of reducing a binary object to a one pixel wide skeleton is so called thinning. Yeah, most of you given the correct answer. Answer C, option C is the correct answer for this question. Okay, so I hope all of you have understand. So now moving to our next question. So next question is a hole in topological terms is defined as a black pixel, option B, a background region completely enclosed by a foreground region. Option C is any pixel with zero intensity and the boundary of the image. Which option can be a correct one? Okay, B. Yeah, that's correct. Option B is the correct. A hole is in topological terms is defined as a background region completely enclosed by the foreground region. So we will see the explanation here. So in digital topology and image processing, a hole is defined as a connected component for a background, and that is the not connected to the border of the image because entirely surrounded by the foreground pixel. So we will check by the options what exactly each option means. So a black pixel. So while holes are often represented by a black pixel in a binary image where the foreground is white, so a single black pixel is just a pixel, not necessarily a hole, unless it is surrounded by a foreground. Okay, so that a black pixel means. A background region completely enclosed by the foreground. That is a correct description of the hole. So a hole that represents a one-dimensional topological feature, that is a cycle. In a binary image, if you have a set of objects that is a foreground pixel that form any loop, any background pixel trapped inside the loop constitute a hole. So topologically, a hole is a background component and it is not infinite or ambient background region. So our next option is any pixel with intensity 0. So this is a definition of the black pixel in a grayscale or binary term, but it does not account for the special relationship required to be a hole. And our option D is a boundary of an image. A boundary is the outer limit of the image grid. In fact, background region is connected to a boundary are typically not considered as a whole. Only internal enclosed region are considered as a whole. The correct option is B. So most of you given the correct answer. Option B is the correct answer. A hole in the topological term is defined as a background region that is completely enclosed by the foreground region. Okay, so now moving to our next question. So our next question is given a four connectivity chain code sequence. That sequence is given 10321. Calculate the first difference of this code. Now we need to calculate the first difference. So here assume four connected 0 is 1 for N, 2 for west, and 3 for south. Here the four connectivity directions have been given. So how we can calculate it? So already we have seen that. So to calculate the first difference or the chain code, each element that is difference is determined by number of the counterclockwise transition needed that moves from the previous code, right? So the difference that is bi is calculated by ci minus ci minus 1. Here it is a 4 connectivity, so that means mod 4 will be there, right? So the chain code sequence is given. So now can you calculate? So first sequence is 1 and last one is 1. So for the first we need to make a closed loop. So the first point is we will take a difference from the last point. So that is 1 minus 1. Here it is a mod 4, right? So I'm just writing 4 here. So 0. Now next one is 0 minus 1 mod 4. So minus 1 of mod 4, so we will get 4, 3, right? 0 minus 1, like this, minus, and again 3 minus 0. 3 minus 0, mod 4. So here 3. Now again 2 minus 3 of mod 4. So here we will get minus 1 of mod 4. So again 3. Again we will the last one 1 minus 2, right? Mod 4. So minus 1. Again here we will get 3. So the resulting first difference is what we have got. The result is that is 0, 3, 3, 3, 3, right? 4 times 3. Yeah, that is correct. So now what we need to do, we need to choose for the smallest circular shift number. So for the standard normalization. Okay. So standard normalization for shape number that is used for the smallest magnitude of the circular shift. Okay. The smallest magnitude of circular shift. So here how many numbers? Four, five numbers are there. So five circular shift will be there, right? So if you just shift by one, yeah, that is correct. So, yeah, just going to the options. So here they are asking for the smallest, but in the options they have given 33330, not a smallest one. So this one is the smallest one because if we just shift it in this the next bit also, so you will get 0. So this is not small. This is not a smallest one. So in the options they have given these. So the three options are not matching. So just go with this option. Okay, because there is no option is matching. So if just first you need to check the smallest one. If it is in there in the option, you can tick that one. If no option is given, so that is a possibility. Okay, but if you are writing, so in that case you have to choose the smallest one. And if it is in the option, it is not given, so you have to choose the whatever option is matching because there five possibilities would be there, right? Five circular shift is possible. In the options, they can give anything. So you have seen in the previous one also. So just check the smallest one is matching or not. And next one is also if you shift 0, 3, right? Now again, for the next one, you will get 0, 3, 3. And then again 3, 0, 3, 3, 3, like this. Again one shift, the same will be there. So these are the possibility of the circular shift. So just check with the options which is the matching. So for the smallest shift, there is no option for that one. So whatever it is matching, you have to check for that. Okay. Yeah, it is not given. The smallest one is not given in the option, but the whatever circular shift you are getting, just match with the option. If the answers are matched, so just tick on that. Is it fine, Ninad? Okay. Okay. So now moving to our next question. The next question is a binary image row of 10 pixels that is given as a 11111 5 times 0. If each pixel normally takes 1 bit and each array count takes 3 bits, what is the compression ratio? So how we can calculate this question? So binary image row of 10 pixels is given. If each pixel they are saying normally takes 1 bit and each RLE count take 3 bits. What is the compression ratio? So here the original image row consists of 10 pixels, right? And since each pixel takes 1 bit, that each pixel takes 1 bit, it is given. So what will be the total size? Total size is, the original size will be, we can write it 10 pixels, and each pixels are taking 1 bit. 1 bit per pixel taking, right? So how many bits they will take? 10 bits, right? It will take 10 bits, right? So in the RLE encoding, we have seen that we have to count the consecutive numbers, consecutive similar numbers. So what is our RLE runs? So five ones are there and five zeros are there, right? To represent RLE, right? We have seen in the one question how to count the RLE bit, right? And in the question, they had said that each RLE takes 3 bits, right? So what will be the compressed size? So the, you can say, I'm just saying that R, because we are compressing through RLE. So in the RLE, how many counts will be there? Two, five ones and five zeros. So only two counts are there, zeros and ones total. So the compressed size is, so two RLE are there to represent the whole sequence, 10 pixels. So two counts are there, two counts, and each count is represented by 3 bits, right? 3 bits. Here it is the RLE count takes the 3 bits per count, right? So here how many totals are there? 6 bits of the compressed size. So now compression ratio is calculated by, we can write the compression ratio. Okay, so I'm just removing it from here. So the compression ratio, or you can represent it, so yeah, that is original size divided by compressed size, right? So original size, yeah, we have got 10 and compressed is 6. So 10 by 6 bits. If you just divide it, you will get 1.66, right? So 1.66, we can write it like 1.66 into 1, right? We can write it like this. So if you just check, so you will see option B is the correct answer for this question. Is it fine to all of you? Have you understand this question? Any problem, any doubt? Okay. Yes, you can ask. You can unmute yourself and ask. So then in that case, we have to count only consecutive ones and zeros. So if it is between the zero and the ones, then you have to break the chain, then you have to count it in different way. So how many numbers of ones there? Like after three, one, there is a zeros. Then you have to count like the three ones. Then you have to make the code. Already we have seen in the previous one question, right? So ones and zeros are there. So three and two will be there. Three ones and two zeros. So like that, you have to make the RLE code, the compressed version of the each pixel. So like example I can give. So like here after 3, here 0 and 0 will be there. Then 1 1. So what will be the array? So 3 ones are there, then 2 zeros are there, then 2 ones are there, and 5 zeros are there. Like this. Already we have solved one question, right? Is it fine? Okay. Okay. So can we move to our next question? So now moving to our next question. So next question is for a 1 day intensity profile Z with values 2, 4, 6, calculate the second central moment mu2, which represents the variance of the shape intensity. How we can calculate it? For a 1 day intensity profile Z with values that is given, calculate the second central moment mu2, which represents the variance of the shape intensity. Okay, so let's solve this question. So for 1D intensity profile, that is Z is given as a 2, 4, 6. So first we need to find out the second central moment. How we can calculate? So the second central moment mu2 formula is summation of, or you can also say Zi minus mu whole square divided by n. It is calculated by this one. So now first we need to calculate mu, right? This mu. So this mu is represented by mean, you can say. So mean is the average intensity value of the intensity profile. So 2 plus 4 plus 6 divided by 3, because 3 values are there. So 12 by 3, we will get 4 mu. Now put in this one for to calculate the mu2. So it is summation of all the zi's. So 2 minus 4 whole square plus 4 minus 4 whole square plus 6 minus 4 whole square divided by 3, right? Now just if you calculate, minus 2 square is 4 plus 0, 6 minus 4 is 2, 2 square is again 4 divided by 3, so 8 by 3. Now further if you just do 2.6667 like, or you can write it 2.67 itself. So if you just check, so option A is the correct answer for this question. Yeah, is a variance. Second central movement is a variance. Is it fine to all of you? Have you understand? Okay. Okay, so now moving to our next question. So our next question is the previous class week 7 question. That is not clear in the previous class, so I will go through this question again. So as I already told you, for an image, the gradient magnitude and direction is given. Direction, it is representing the direction. Okay, it is given. So after performing non-maximum separation, which pixel represents the local maxima, right? So now we need to this one, which pixel represents the local maxima, right? So now what we will do in the options, if you check that, so only these three, right? See, till here to here only. So without comparing all the values, it will be a very lengthy process. So we will focus in this region only. So we will compare these points only. Okay, because they have concentrated in the option in this one. Okay, so we will check. So in the highlighted part, we will go through that. So already, as we have discussed, so non-maximum separation is used in edge detection to thin the edges. For each pixel, its gradient magnitude is compared with the magnitude of its two neighbors along the direction of the gradient. Okay, so here the direction of the gradient that is given, the point up left. So that is corresponds to 135 degree direction. So that 135-degree gradient pixel must be compared to the neighbors like northwest and southeast diagonal. Okay, so only northwest and southeast diagonal. Let me just take this image to here. Easy to describe. Okay, so already direction is given, that is 135. So we will go through. So it is a 5 cross 4 matrix, right? So that the pixel 2 2 that is written in the rows and column, right? Like second row and second column. Okay. So if you check second row, second column is that is 309, right? 309 values there. So the neighbors along the direction that northwest, it is in the this one, that is 51, and north southeast, that is a in this direction, that is a 401, this value, right? So if you check that, so 309 is greater than 51, but it is less than to 401, right? So it is less than the 401. So that is a not a maximum. So that's why we will suppress this. 309 will be the suppressed one. Okay. Now similarly we will check for the second pixel. 309 is done. Right. So we will go to the next pixel. So what is our next pixel in the that is second row, third column, that is 309 398. Now check the its north, west and southeast directions diagonal value. So that is one is 143, this one, and another one is 388, right? So if you check that, so 398 is greater than 143 and it is greater than to 388. So that means if it is a greater than, so that is preserving the local maxima. So that's why we will keep the 398. We will keep the 398. Okay. Now similarly we have to do to the next pixel, that is a 408 to second row fourth column, right? 408. Now check for the neighboring pixel 276 and 404. So if you see that 408 is greater than the both the pixels, that why it preserve the local maximum. That should be keep. We need to keep it. Okay. So now similarly we need to check to the next pixel, that is we are just concentrating in this because in the options only this part it is given. That's why we are concentrating in this. Okay, pixel that is highlight in the option. We don't need to compare all the pixel. That is a very lengthy and time consuming process. Okay, so now we will go to the third row and second column, that is 408. So 408, if you see that there's a north west 176 and it's the southeast is 353. It's no, it is for 391, 408. So 408 is greater than 391 and 176. So that means that will keep, right? Similarly, you will need to check the 401. So 309 and 353 will be there. So 401 is greater than with the both. So that's why we will keep that one. Now next one is a 388, the last one, right? So 388 is northwest 398 is there, 398, and next one is a 319, right? So here 388, so 388 is less than the 398 but greater than the 319, right? So it is less than the one neighboring value, so that's why we will, it is a not a maximum, so that's why we will suppress it. So what final values we have got that we need to keep it? So this one is a 398, 398 and 408, right? And 408 to 401. So this one. So that is. So if you just see, so option A is the correct match for this answer. Now it is fine, Ninad. Now this clarification is okay or fine, or any doubt is
Yes,
there?
ma'am. It's
Okay,
fine now. Thank you. Thank you.
okay, yeah. So now we will check. There is a one question in week 7, question number 8. So there is a one image is there, right? So their code is there. So are you able to see my screen, the another one? Just let me share it everything. So is it visible now to all of you? My screen is visible. Anyone? Can you answer? Okay. So are you able to see the code? Okay. So this question is that there is one image is there and there we need to find the edges, right? With using the different kernels. So four options are given, the four different kernels. So I wanted to say, actually I have taken the screenshot of the image, so that image is not clear. So if you download the original image, so you will get the correct edges. So that's why some blurring and some extra effects are there. So if you just check, so there is a one option, and the fourth one is the correct one, kernel D, that is a vertical. Here the all the upper rows are positive, right? Last one. So this one is a positive and other one is a negative. So if you see, this is a representation of the different kernels. Just I wanted to show you. So is it fine? Are you able to visualize in that case? What is the exactly how it is performing? So it is updated. This is included in the slide. If you just open that link, you are able to just see and download the code. So in that case, it is better to understand how the, I mean, vertical edges and horizontal edges is performing, how the kernel affects the image edges. Okay, so that's why I want to make you visualize. So you can just see and just download the original code and just check this code. Okay. So for this week, the questions have been completed. So yeah, thank you everyone. Thank you for joining the session. Now, if you have any doubt, you can ask. Otherwise, we can close the session.
Ma'am, can you also share this code, or have
Yeah,
you
yeah,
already
yeah.
shared?
It is. I have uploaded the slides. Okay. So you just copy the link
Oh,
and open in the
okay,
browser.
okay,
You will able to visualize, and you can download it itself.
okay. Thank you.
Yeah.
Thank you.
Yeah. Okay. Thank you everyone. Thank you for joining this session. If you have any doubt, you can ask. Otherwise, we can close the session. Any doubts? Anything you want to ask? Okay. Okay. So thank you everyone. Thank you for joining the session. Now I'm closing the session.